Okay, so to start off with shale gas, it is very easy if you live here in southwestern Pennsylvania to think that we are the center of the world on shale gas. But I wanted to start with telling you that we're not. Shale gas is a global phenomena, and this is an image just to show you some of the resources in shale gas that we know about. The very light gray are areas in the world where we just don't know. So just about everywhere we've looked, indeed, we do have shale gas resources. I will not say the words game changer. I will leave that to all of the folks on the economic side. But there is a major resource in shale gas on the planet, and that is likely to change how we deal with our energy resources. And in case you were unaware, there's a lot of water on the planet too. Just about everywhere on the planet. And if you look at the world from space, mostly you see water, but I'm here to tell you that all that green stuff, there's water underneath that. So almost everywhere that you find shale, you're also going to find water. What this means is that our water resources and our shale resources, in fact, all of our energy resources, are co-located on the planet. So shale gas extraction is, of course, going to happen near water. Everything happens near water. We're up here on the surface of the earth, those tiny little bitty things, you can barely see the people I drew in here. That's us. Okay? Shale gas extraction starts on the surface of the earth, but then, of course, we have to go down, all the way down to where the shale is, drill through all of these layers of earth, through that tiny little sliver up here that is the aquifer from which you're receiving a lot of your drinking water. We have to go through all of those resources to get to the shale. We drill through and we send water down through in order to hydraulically fracture the shale, which is break the shale into little bitty pieces so that the gas flows back to the surface. What that means is that when you do this kind of development, it's critically important that you protect the surface water from spills of the chemicals that we use in this operation and of the water that comes back to the surface. That is hardly surprising. There are no industries really where you wouldn't say there's a potential for something affecting our water resources. It's also critical that we isolate groundwater from this drilling activity and from the hydraulic fracturing chemicals. That's a fairly unique aspect of this industry, but again, all industries affect our water resources and our wastewater and generate wastewater. Shale gas extraction is particularly known to use a lot of water and to generate a significant amount of produced water. So a typical shale gas operation, and this is one in West Virginia, will start with 1 to 5 million gallons of water, perform a hydraulic fracture operation, generate 10 to 15% of that water will come back to the surface in the first couple of weeks, and then water continually is produced out of these formations along with the gas. That's a significant amount of wastewater to deal with. We call that water produced water because it's produced when the gas is produced. When the gas stops, so does that water. But all the time that the gas is coming up, we get water that kind of looks like this. Now, if you're from southwestern Pennsylvania, that just looks like the red water we have here everywhere. But I'm here to tell you that it's a lot worse than the kind of things we see in acid mine drainage because it's highly concentrated. It contains the residuals from everything we put into the hydraulic fracturing, as well as some naturally occurring radioactive materials, a lot of salt, and some chemicals that we typically find with hydrocarbons, benzene, toluene, ethylbenzene. That water has to be managed and dealt with as it comes up from those formations. So first, understand that 1 million gallons of water takes up a considerable amount of space. We have to store the water on site. We have to store the wastewater when it comes back up. Every so often, you're going to have to go back to every single well and pick up the wastewater. You're going to pick it up in trucks. We're going to truck the water to the site, truck the wastewater away from the site. There's a significant increase in truck traffic and in the potential to have accidents with these trucks full of waste. We, of course, can also treat it. I like to tell my students that I can take any water you give me and make it drinkable. All it takes is a little money, a little energy, and I can go from the worst sewage you ever invented to completely potable water. But of course, energy is why we're drilling the wells. So you got to be careful with how much energy you're going to spend to clean up the water that's coming back up. You can also dispose of this water down deep wells. You may have heard of this technique. Here again, us on the surface of the planet, Deep underground, there are locations where we can put waste. We do quite a bit of underground injection in this country. 1 billion gallons a day of produced water is injected somewhere in the United States to dispose of it. So there's a lot of water going into deep underground injection. So I only have a little bit of time, so I'm not going to be able to tell you really about how much water and how much wastewater we're talking about globally, but I did want to briefly tell you about a little of the work taking place here related to this issue. So now I'm going to focus down. Remember, it's a global problem, but I'm only going to talk about Pennsylvania. How much water does it really take? How much wastewater do we really get? So first on the how much water, this is some work from a couple of my colleagues in engineering and public policy, Austin Mitchell and Liz Kasman, who have been looking at here in southwestern Pennsylvania, how much water withdrawal are we using? Now those of you who live here have said, you know, it rains every day, really, who cares how much water they want? But we did take a really careful look at how much water are we talking about. Water is withdrawn both from small creeks and streams and rivers, that's surface water supply. Maybe around 55 million gallons a day is permitted withdrawals into Marcellus Shale Development. And then public water supply, you probably can't see, but these are fire hydrants, or they would be fire hydrants, but they're hydrants lined up for shale gas water sales. So public water supply may be 35 million gallons a day. So we're talking about something around 90 million gallons a day of water going into this industry. That sounds like a lot of water. Pennsylvania American and Pittsburgh Water and Sewer are our water companies here. Pittsburgh Water and Sewer withdraws 100 million gallons a day for just the city of Pittsburgh. So we're talking about the water use of a mid-sized, can we say big? Can we say Pittsburgh is a big city? Big city. So about the same water use of a mid-sized city in the United States. It's not a lot of water. What tends to matter on water is where you're getting it. Small creeks are impacted more than, if you want to take this out of the Monongahela River, if you want to take this out of Etna during flooding, we're all okay with that. How much wastewater? Last thing I want to talk about is what happens to all of that produced water. So this is some analysis my group has done looking at produced water volumes in Pennsylvania 2001 to 2011. Total produced water we know for this first period, and then we know it broken apart for Marcellus and non after that. So about 10 million barrels or so of produced water, maybe a little less, 8 to 10 million barrels of produced water were being produced every year in Pennsylvania for a really, really long time. We've been drilling holes in the ground for hydrocarbon extraction in Pennsylvania for more than 100 years. So this is our background produced water levels. In 2008, with a sharp increase in Marcellus shale drilling, we saw a significant increase in produced water loads coming out in 2008 and 9, a drop in 10 and 11 with a significant increase in recycling within the Marcellus shale formation. But you still see, now that we know the conventional from the Marcellus, see this dark blue down here looks kind of a lot like it's looked forever. Right? So, sorry about that again. So our produced water levels from conventional have stayed about the same, but the Marcellus production is generating a lot more of this water we need to manage and deal with, about twice as much as conventional in 2010 and about 3 times as much as conventional in 2011. So what's the story with water and shale gas? Protecting the ground and the surface water while we're doing the development. Managing the water withdrawals. It's not too much water, but you have to be careful about where you're taking it from. Protecting the water resources when we transmit, when we ship this material, and when we store it, and then finally appropriately treating that significantly increased volume of wastewater that we're seeing. And with that, I will just remind everyone in the room that professors don't do work students do. And so on this side are all of the graduate and undergraduate researchers who have helped with the research that I've just presented to you, and our funders, Steinbrenner, the ARCS, Colcom, and Heinz Endowments have all provided funding for this research. Thank you.